I'm very excited to introduce you to Dr. Andrea Sánchez Tapia. It's the very first time I meet her after 2.5 years meeting her virtually, so very good, very good. So Andrea is a biologist with a bachelor degree from Universidad Nacional de Colombia. My accent is terrible, but she's from Colombia then. So Andrea moved to Brazil for a specialization in environmental management in 2007. Got a master's degree in ecology from Universidade Federal do Rio de Janeiro in 2009. And then a PhD degree in botany from Jardim Botânico do Rio de Janeiro. If you don't know, you should go. What else I can tell about her? More recently, Andrea was a postdoc researcher at the Jardim Botânico as well, right? And her work is mostly in plant ecology, many things, ecological niche modeling, and biodiversity informatics. And she's one of the few people that describes herself as a biologist that does biodiversity informatics, and I like that. As Sarah, Andrea is very interested in open, reproducible, I never know how to say it's reproducible, reproducible, whatever, something that you can make it again, and responsible science. She organized the Our Ladies in Rio, and she also collaborated with the Turing Way project. If you don't know, you should look for that. It's very cool. And she's also one of the Libre founders, right? I like this lab a lot. And also a member of Observatório Covid-19 BR, where she helped to make the codes available to everyone and the data, when possible, the most easily available to everyone. Nowadays, Andrea is living in the US, in California, working as an independent researcher and working as a freelancer. So she works a lot helping people to make science responsible and making science open as well. I think people like Sarah and Andrea make us to move towards a better science, and although she and Sarah are not in the traditional academic sites, right? They're helping a lot to make a new generation of scientists like you to develop a better science that is open and responsible. And I think that's it. So help me to welcome Andrea.
Hi everyone, I am so happy to be here. I hope you are hearing me. If I get excited, I will start to yell a little bit, so I'm sorry in advance. So thank you, Flavinia, for the introduction. It's true that we have been working online these 2 years, so it's so nice to be here. I have been sitting here, like you, in the past, and it's so nice also to come back to the ICTP in this side of the room. So yes, being here really made a difference in my career, because I came here in 2018 for a Codata summer school about open science, and it was very nice. And we have, and 2 years ago I was here in a summer school, a modeling summer school with Roberto and other people that you probably will know during these weeks. So thank you. And the other thing is that, as Flavinia told you, like I teach computational skills to undergrads and to grad students, especially in Brazil, because I lived here for so long. I have no idea how this works.
Is there mic?
And I don't know. Okay.
I don't know.
No, that's okay. And I am used to teach with Sarah at the same time, in the same room. So while Sarah is here, I will be around the room, and vice versa. If I am talking here, Sarah would be with you, and we always complement each other. So this is new for us. She was here, and now it's me, and we are sometimes we say the same things, we say the same jokes, bad jokes, and sometimes it's, you can see definitely the differences in our way of teaching things. So this is going to be partially overlapping. I might repeat some things that she says that we are very, very into teaching. She must have told you about good practices, about folder structures, these kind of things. About code styling, she loves to give that part. And, but some of our approaches are a little bit different. So I will try to keep the sequence, and we're going to change a little bit topics. But yeah, this is, hi. Hello. Okay, thank you. I have, and but if you have any doubt from her part of the course, if you still have questions, if I say something that is clashing a little bit, or if it's complementary and you have doubts, you just stop and say like, hey, we were doing this like this way, and why are you showing me? This is part of the work. When we work together, when we do programming and scientific programming, and when we collaborate, that happens a lot. You have a way to do things, another person has another way. It's just a question of communication and of doing the best way and finding a way to work together while doing, like, respecting each one's styles, but also like entering consensus. So I am here. It's not a continuation, but it's also a continuation. Sarah says hi. She liked it very much, and now it's my turn. I don't know if you have any questions, comments from the last weeks, if you have anything that you might like to. We just lost our Slack channel. So maybe we will come back to the notepad. If you have questions or if you want to communicate anything or some notes, we might come back to a shared notepad because we don't have Slack anymore, okay? I don't know.
Just the slides?
Yes. So some of you may have worked already. What I'm going to do today, because it's our first day and we're just going to get to know each other, is a short and shallow introduction to spatial data in R. After this course today, tomorrow we will see more spatial data that is occurrence data, species occurrence data, and how to work with them in R. And it's something that you might need during your careers, because there are so many applications of spatial data in so many areas of science. I will just try to. Okay, so Flavia already said something about me, but I was just going to let you know. Yes, I was here in Brazil. I am Colombian, and I came here to my graduate studies. It was a lot of vegetation and field work, and I work with restoration ecology, and I like to work with people. And what happened is I became more and more theoretical. And while I was working in more and more theoretical things, I started missing the contact with people again. So what happened during my PhD is that I started communicating a lot with communities of practice, of programmers outside of academia, but not outside. It's people who are in different areas in academia, and they come together because of their interest in some topic. So this is how open science and the interest in reproducibility came. And I was working at the scientific computation lab at the Rio de Janeiro Botanical Garden. I am not a very, very good botanist, but botanical gardens have databases, giant, massive databases, and they have lots of interesting applications of the data. So I was at the scientific computation lab, and we had some collaborations that made us develop some R packages and develop some workflows. So that was part of my job. And this is how our course, and this is a picture of our course. And this is Sarah. So this is how we developed this in the past. And I am part of the R ladies too. I am part of Latin R community. And recently I have been working as an instructor for the Carpentries. It's an organization that teaches computational skills. And in the Turing way, I will talk a little bit at the end of our 2 weeks together. because the Turing Way is a guide for reproducible science, and it's a collaborative guide. Everybody's welcome to go and read and study and contribute if they want to, and if there's a topic that you want to study or if there's a topic that you want to add, it's collaborative. So it's the spirit of this kind of communities, and that's why we work a lot with them. Yes? So that's basically. So back to spatial data. I don't know if we asked at the beginning of the course if you had some experience with GIS data, with geographic information systems. And not everybody had experience, but some of you are interested in, for example, movement ecology and track ecology. Can I have like a hands up of people who already know something about spatial data? Okay, perfect. So I am going to talk about spatial data, but it's going to be super introductory because not everybody in the room has this experience. And what happens when people talk about GIS is that we have very famous software suites, programs, like ArcGIS from Esri, that are extremely powerful. They have been the leads in the field for a long time, and they are extremely powerful, but at the beginning they were only point and click. So you had to go through the interface by clicking, clicking, clicking. If you had to redo something, you had to click again. So this is bad for reproducibility, even if the tools are very powerful. So with time, what has happened is that some integrations have arisen. So now, for example, you can work in Esri, ArcGIS, using Python code, using JavaScript code. That happens with other suites. But another problem that we have in South America and in some institutions is that this is paid software. And lots of people learn how to use this without a license, and this is not the way it should happen. We should be able to use free software, and it's definitely important. Sometimes you are in institutions that have the licenses, but the importance of free and open software for doing some work is real. So right now, 4 of the tools that we mostly use for spatial data are R and Python, of course. And there are some GIS like GRASS and QGIS. QGIS is kind of famous. And it's like the competitor for ArcGIS right now. For some things, it's more powerful. For some things, it is not. The important is that you get to do the job if you need it. All of this work in geography are based in some external libraries that were developed in C and C++, like GDAL, like Proj, and GEOS. So these are libraries that you can install in Linux, for example, but in all operation systems, and that are maintained by the community. I don't know if you are hearing me well. I am just listening. And some of these libraries are the basis for for example, the R packages that we use in spatial analysis. And there have been some recent changes. These are standards that change the same way that all standards change. So they are evolving. And I am right now going to talk to you about something that is exactly changing right now. Like if we talked about spatial analysis 5 years ago, the set of packages, and it was kind of stable. But right now, some packages are going to be deprecated at the end of the next year. So we are not going to be super deep into the past standards. But I cannot also talk a lot about the new standards because they're just being built. So we are going to talk about what is happening right now. But I just wanted to let you know that there are some key changes that are going to make this field a very dynamic field in the next couple of years. So in R, spatial data have been supported for many years. We had a classic package, it's SP, but we have ways to do maps in base R. You could just plot your points, and you could make maps fairly easy. And some classic packages that were part of this initial suite are going to be retired. And we have a proliferation of new packages that deal with larger, faster data and remote sensing data. And depending on the question of your work, you choose the tool. So we are not super strong about what you have to decide. You don't need to pick a tool and stick with it and not change, but just to explore a little bit the panorama. So today, I'm going to talk especially about Raster, SF, and TMAP. Raster is the classic packages to lead with raster data. SF is the new standard for spatial data in R in general. So we are going to explore a little bit how an SF object works. And TMAP is a package for thematic mapping. You should be able to do simple, quick maps with a syntax that is similar to ggplot. So if you're already working with ggplot, it has a little bit this pipe, the pipe syntax. You start doing and you add some features. We're not going to go super deep, but this is like what we're going to do today. Do you have any questions, any comments? Do you know these packages? Is okay? I will come with post-its tomorrow. For those who haven't seen spatial data ever, the large difference between two kinds of data are vectorial and raster data. When you look at a map, this is a map of a biological preserve in Rio de Janeiro, and we have the limits of the. Do I have a laser here? No, I don't have a pointer. No. Oh yes. No. Okay. So we have the limits of the area, and we have some features in the space, like a road and a river. And the green areas are areas that are currently recognized as Brazilian Atlantic forest. The dots are plots, and the gray areas are areas that have been burning repeatedly. So this is a basic map. It has not a lot of information, but it's visual information for you to understand an area. We have an indication of the scale, and we have indication of the orientation of the map. When we're talking about these kind of features that are polygons and lines and points, we're talking about vectorial data. So basically, you're talking about points. It's pairs of coordinates in the space. And we talk a lot about multipoints, because it does not make any sense. If I have 12 plots, it does not make any sense to have 12 objects. I have one only object that has lots of points, so it's still a point feature, but it has multiple points. Like when you plot all the cities in a country, it's lots of points, but it's a multi-point feature, so it's still point, even if it has many elements. The same thing happens with lines. When you have a line, you have basically several pairs of coordinates that are ordered. You tell the order of the connection, like the river. You tell what is the order, which point connects with which one. And you can have polylines and multiple objects in the same space. So one river would be a line, but a river and its tributaries, or all the river system in a country, would be multiple lines. The same happens with polygons. You have ordered polylines. They have to be closed. Unlike roads and rivers, a polygon, an area, a country, a department, a state, reserved area has to be closed, so it has to be careful about the geometry. And it can have holes, for example. You can have, for example, a lagoon inside an island. You have to be able to do this kind of operations where you have holes in the polygons. It's not full. And when you have multiple polygons, like when you have an archipelago, you have a system that has lots of polygons, it should exist. So this is the basic types of vectorial data that you will have. So you will see when you explore vectorial data in R, you're going to see a lot of these words: multipoint, line string, multipolygon. I have never seen a geometry collection in nature, because what is lines or points or polygons? I have never seen somebody do this. Maybe I have created something like, no, not even making mistakes. I have seen like this kind of mix, but I am guessing here that that exists. So the geometry collection is not something that you will be looking at a lot. Please.
We didn't have that in the previous
Excuse me?
image. We didn't have that in the previous image.
Oh, okay. He's asking if we have this geometry collection in the previous image. So we have here lots of polygons, and we have lines, and we have points. But this map was created by superimposing things. So it's different objects that create a visual representation, but there's no one, it's not one element. So what you do is you put the forest, and then you superimpose the reserve, and then you superimpose the burned areas. So it's not exactly the same. When you look at it, it looks like that. But what happens on the background is it's very difficult to see an object that is that. So you just superimpose. Yes, I will. Thank you. I also have to tell you that I am super hard of hearing, okay. So I will need the microphone.
I'll ask again. I was just asking if in the other case that you told us that they have like layers of this is the best practice and not put all things together in one.
I would say so, yes. And what happens is that the sources are different. What happens is, for example, it's not only a good practice because you wouldn't want to mix the data into one only element, but also when you compose a map like this, it's not one source. You will have to have an institute that gives you the forest information. You have another institute that gives you the geographical features that do not change. You have your field data, for example, these are plots that are in the field. So not even like blending them together would be missing this origin. So I think keeping separate things separate, and when we save those in the computer, I do like separate subfolders, like raster data and spatial data, and I try to make it very organized because the computer will lead with this. Yes, is it okay? So when we talk about this vectorial data in computers, we talk about shapefiles. So the object, like the file in your computer, is a shapefile. And basically, you have 3 mandatory files. It's not only one file. It's going to be like a little folder with files inside. And one of those is the projection. This is optional, unfortunately, because sometimes you have the information that delimitates your polygon, and sometimes you don't have the projection, like in which geographic coordinate system it was created, so you have to infer from the data. That occurred especially with all data. Now, most people try to keep a projection data, and that's a good practice that not everybody follows. So it's a collection of files that will paint your features. But the shapefile is not the only extension, and there's no way I can tell you about the other files, but sometimes you talk about geopackages, and geopackages are also another way to store shapefiles. In R, the package SF is the one that reads currently shapefiles. We have this website, you know about the website. So the website has a special tools introduction. And there are the 3 packages that we were going to use today are there. I don't know if you install them, if you had trouble installing them, if you are going to install them. I should have asked you yesterday, but I was in the middle of a trip. So just let me know if you want to install them. It's SF, TMAP, and raster, basically. And part of the possibilities, SF, raster, and TMAP. And I am okay, like if you have trouble installing them, it's okay, because sometimes these libraries are complicated to install. And it depends on the current state of your computer. If you have already previous installation of other packages, or depending on your operating system. When you have time, and when you can install these 3 packages. And if you have a collection of errors, I can check with you later today which errors are you getting, and how can we just circumvent them, okay? That's why I wasn't very worried about installation, because it's almost certain that you will have problems at the beginning. It's different. It's going to be different for every one of you. But if it installs fine, it's very good. So, I will stop talking about shapefiles. The other kind of data is the raster data. And raster data are basically continuous space divided in a cell grid. When you see temperature data or altitude data and continuous data in space, it's going to be raster files. And it does not have these geometry characteristics. It does not paint pairs of points in space. What a raster looks like when you look at it, depending on the format. You have a continuous space that is gridded. It has an extent. The extent is what happens, what is the x mean, and what is the x max, and the y mean, and the y max. And for example, in this raster of altitude in Brazil, all the white parts are NAs. So it's NA, NA, NA. And at some point, you have data. But the whites are NA, so it's a square. You have a bounding box. I am not very good at doing this. A bounding box with the limits of the raster. And the rest of the data is NA. So sometimes when you put a point, a vectorial shape in a raster, you find an NA in the raster file. So it's conceptually different, but I think it's okay. It's easy to see the difference. Is it okay? Okay, perfect. I don't like this. Wait. These rasters have one value per cell. So sometimes they have to have an extent, and they have to have a resolution. You could have little squares that are 10 kilometers, or maybe in meters, or maybe in seconds and minutes, because it's degrees, it's geographic. Or you can have rasters whose resolution is very high. So this is a pretty high resolution. And what happens when you have the spatial extent and the resolution? Can you take my image away, Natalia, please? Yeah, okay, perfect. Is that you have a number of rows, a number of columns. So in this case, for example, we have these dimensions in the x and y. It's 4716. The numbers in English. Wait, 4,716 rows and 5,388 columns. In R, if you remember, I don't know if you have. In R, the lines are always first. Okay, so and D1 is the number of layers, because altitude is only one layer. You could have multiple layers in a data set. For example, the maximum temperature, the minimum temperature usually comes on a monthly basis. So you have the maximum, minimum for January, for February, for March. So you have three dimensions. So a raster can be one, or it can be a stack of rasters, or it can be a multi-band raster, which is similar. It's just, it has more dimensions in the layers. And in our raster is the package that works with raster files. And you have several file types, ASCII, grids, and TIFFs. It does not make a lot of difference today, but sometimes you have software that only can read one type of file. There's another one that's called .bil. And sometimes when you do some analysis in some software, the software only reads .bil. So you have to be able to read, you have the information in TIFF, you have to be able to transform to read it in the software. R does not care a lot about this, but it depends also on the data source, because sometimes you download the data and it comes in only one kind of file. So far, so good? Any questions? Huh? Can you? Yes, please.
I just want to ask if we are going to see netcdf files too.
Not today, no. But
Okay.
netcdf are files that are for remote sensor. Do you want to tell us why you want to, or like why, from where do you?
No, because you can use netcdf in the place of other types of raster files.
Yes.
So I just thought about that.
Yeah, no, that's true. What is your name?
Gabriel.
Gabriel. So what Gabriel is saying, Gabriel is talking about a file that is called, a type of file that is netcdf. As far as I know, netcdf is not read by a raster package, but by other packages. And netcdf is the standard for remote sensing, so data from satellites. So today, we're not going to go until that point. We're going to stay in the introduction. But if any one of you wants to understand and read satellite data, and it will come in netcdf, you just, I think the package is called netcdf. Yeah, exactly. So you download this package, and this is the way you enter remote sensing data to R, okay? But yes, thank you for mentioning. So where to find your spatial data? Yes, of course.
Well, since we're talking about file formats, is there a difference between TIFF with one F and two Fs? Because I've seen both. And I don't know, one, my image reader does read, and the other one it doesn't.
I didn't hear the last part.
Yeah, because some programs only can visualize TIFF files, but if it has the double F
Yes.
or something.
I know about that. As far as I know, it does not make a difference. It's, maybe you know the difference. Okay. It's like JPEG and JPEG.
I know, I know nothing. It's working?
You can, yeah.
Okay. I know nothing about such files in ecology, but when I have to scan a book and make the file from it, there are sometimes you produce TIFF files which have that F or not. They are the same. The data is arranged the same,
Yeah.
so the program simply expects having another F or not
Yeah.
having it. So it's that
Yes,
ridiculous.
it's the same thing. Because you have photograph, like when you work with design, graphic design, like Photoshop and the classic GIMP and the two extensions exist. I don't know why they exist, but they are interchangeable, except when you read and you put the bad file path. You cannot say, please read photo.tif. If it has the 2F, you have to put the 2F. Most of the time, the data in R has only one F. The TIFF with two files is like more graphic design and photographs. That happens like JPEG and JPG, like the pictures. It's because standards proliferate. So I have no idea like the origin, but it shouldn't make a difference. You will mostly see TIFF without the second F. So where do you find this data? When you want to make a map or when you want to start seeing the geographic features of some place. For a long time, and sometimes it's still true, you have to go and have direct downloads in official country organizations. So for example, here in Brazil, you go to the IBGE, it's the Statistics Geographic Information Institution, for those who are not Brazilian here. And it's the IBGE who will tell you which is the official shapefile for the country. this has to happen in other countries. And we have sometimes, for example, IBGE leads with administrative boundaries, but it's the Ministry of Environment, the databases, that lead with protected areas. Like what in Brazil, the protected areas is called the SNUC, the National System of Conservation Units. So you go and take the data from the SNUC directly from their source, and this is the official one. And sometimes when you have proxies, sometimes you have an organization that says, hey, I took all the administrative data for the countries and I put them in a single site so you can download it. Sometimes it's not updated, because what happens in every country cannot be, it's not sometimes like very, 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 you cannot update it regularly. This does not mean that they don't have errors. Sometimes you make the download and there's a complete feature missing. Like sometimes it happens. So it's official, but it's not necessarily not error prone. Sometimes it's super error prone. And you have, I was talking about these kind of repositories that put together the data. So for example, for administrative areas, there's GADM. It will have information for administration for all the countries. It has some mistakes depending on the country. But sometimes you need some countries that do not have this information readily available, or countries that you don't know which is the official institution, because sometimes if I want the information for Guyana, I could do the search, but sometimes I won't have exactly, I don't need this kind of details. So some repositories have general data. And there's remote sensing data depending on who's providing it. And for example, the satellite data, MODIS, Sentinel, Landsat, depending on the source, you go and download it. Right now, there are packages in R that can make the download. Some R packages have some internal data that you can just use if you don't need the extremely detailed information. And recently, there's this R Spatial Data initiative that is putting together a collection of data sources and tutorials on visualizing spatial data with R. So this is not super recent, but it's pretty recent. And it has different kind of information. So if you go to the page, it will have some tutorials and some packages that have this. So you can download directly from R without going to lots of sources, or at least you will have the references. So now I have to talk like quickly about coordinate reference systems, because it's the standard that you will find the objects in geographic space. So we have one global CRS that is currently WGS84, so it's the World Geodetic System. It was created in 1994, and the names of the CRS are like this. It has usually some letters that indicate, for example, the South American datum is SAD, and the year. And you have official, since not every country, not every region is mapping itself according to the rest of the world. You have national organizations, national geographic organizations, like, I don't know, in Colombia it's the IGAC, the Instituto Agustín Codazzi. Here in Brazil it's still the IBGE. So they define the CRS for each country. So currently in Brazil, it's CIRGAS 2000, but for a long time it was SAD 69, that was the South American data. Yes, in Colombia, when you have maps, official maps in Colombia, it's in meters, and it has, the only reference is the area of Colombia, and it has UTM projection, so it's different. And it has to be like this, because for a long time, nobody had information, nobody had GPS. Like right now, it's super, super cool for us, like super, super useful for us. We think the GPS was a technology that was, GPS have been in place like for 25 years. The handheld GPS that you went to the field was something that was not existed. So the only way you had to have a map and to know where you were was somebody doing this in the local scale, producing the maps for your country, your area, your region, and then you would kind of find where you were. But you didn't have this in the cell phone. So there's a proliferation. There were lots of coordinate reference systems made historically for the purposes of the work of the person who did the CRS. And there are some pages, like spatialreference.org, if you want to, that have all the lists of different things. So if you are in a region, you're working with information from a region that you don't know, or with a CRS that you don't know, you go there and it has the whole official systems. And there are lots of CRS that are deprecated now. They are old. Nobody uses them because they were updated. So for example, the USA, they had a North American datum created in 1927. And it worked until they updated it to NAD 83. So some old data will still have NAD 27. And if you want to work with them, you will have to transform them to NAD 83. And all of these will have to be transformed into WGS 84 if you want to put together information from different countries. Cool. As I told you, this was going to be an introduction. Like I am not going to spend time, I wouldn't be able to spend time on the elements of a CRS. But basically you have a different model of the shape of the Earth, because the Earth is, okay, not plane, but it's not a sphere. It's not even a semisphere. It has lots of irregularities. So depending on when you are on Earth, you will have to have a different model of the shape of the Earth. And you have to have a reference for the coordinates and units of measurement. Sometimes if the area is too small, you prefer to do it in meters. That's why I was only talking about X and Y. Sometimes these X and Y are longitude and latitude, but sometimes it's meters. Sometimes it's northing and easting, because the system of coordinates that you have is in meters. And you have to have a projection, which is the way to translate the 3D form of the Earth into two dimensions. So you may have heard, for example, Mercator, which is one of the most famous projections, is a projection that gives the countries in the northern hemisphere a wider size than in the south. So this kind of choosing of projections, it makes a difference on if you are seeing sizes correctly and shapes correctly, and this is part of it. So basically what we do in R is we try to understand in which CRS the original data is. You cannot put together information that is in different CRS. And sometimes what happens is that the information does not have a CRS. If you make download for Brazilian data and it does not have a CRS, you have to infer it was SAD69 or Sirgas 2000. You cannot infer necessarily that it is in WGS 84, because the official data are not in WGS 84. Like the country has laws about this. And sometimes when it's missing, that's what I was saying this, you have to assume it's WGS 84, for example, if it's from a GPS, if it's from a worldwide site. But you have to triple check what makes sense in the context of the data you have. And sometimes you plot things together and they do not match because of that, because it's different, absolutely different. You can assign an object to a CRS, but assigning a missing CRS out of the top of your head does not make it necessarily correct, so you're error prone. And it's not the same as reprojecting it. It won't transform the object. So one thing is having or not a CRS, and another thing is going from one CRS to another. That's a second operation. Everything okay? Perfect. I'll just drink some water. And this is only the beginning. So we are going to do some exercises in R directly, hands-on. But this is only the beginning. Like some of you may be interested in spatial statistics, in geostatistics and kriging and something related to local processes and patterns. Some of you may be interested in movement ecology that has a different set of tools and statistics behind it. Spatial data are key for epidemiology and of course for biogeography and geostatistics. I have put some links with references to other material in the site, but we should just go to an R session, a clean R session. So yes, some resources here. So right now, for epidemiology and for health data, Paula Moraga's book is a good introduction. It's a nice introduction. It has introduction to spatial data in R. There's an official page of the workforce, the task force that is working with spatial data science. We have some leaflet is one of the tools that I won't be showing you today, but it's interactive. It looks like Google Maps, basically. We have this book about geocomputation with R that has lots of information about how to deal with spatial data. And of course, there are academic references about spatial ecology and similar. Yes, so this is only a few. But if you have new things, or if you have doubts, or if you find things, just make sure we can just put them together and still put them in the site. I don't know if Sarah, I don't know, but like the site is going to be on, and we can put things on top of what there's already. It's just in construction. I would like to go to, I don't know if you want to make a pause. Do you make a pause? How does it work? What time is it? And we can open a... ¿Qué horas? Okay, so 15 minutes. Do you want to stop until 12:30? So I drink water for a second and we open. Meanwhile, there's a tutorial. Meanwhile, you can do this. This is the, I don't know if you're seeing, yes. I'm trying to put more. So you already, I guess that you already had ggplot in the system, but if you can install SF and tmap and tell me if you have any trouble, that would be cool. As I told you before, there are some external libraries like Proj and Geos and GDAL, GDAL. So package SF should install and link to them. It's a longish installation. And when you perform library SF, it should give you some information like this, linking to GOS, GDAL, Proj, or something like that. If you're okay, if your installation goes well, just let me know. If it does not go well, just let me know. And we can also work in an RStudio Cloud instance. Did you work with RStudio Cloud with Sarah? Okay. I can show you if you have trouble installing. And later, if some of you had trouble installing, but you want to still insist on your computers, you can check the documentation here. It's all in the site. So I will be back in like 5 minutes. But let me know if you have any questions, if you have any doubts about the applications, if you're... Vou beber água lá fora. Espera aqui. Vou beber água lá fora. mejor. So I think everybody was able to install the 3 packages. Some people who are in Ubuntu had to make an extra step and install a library, but it went well. I was a little bit, that's why I created the RStudio Cloud session, so in case there were some problems, extra problems. But this is something that SF made it very easy, because when we had to install SP, you had to do lots of work outside. So install GDAL and install RGDAL, and RGDAL is going to go out. It's the previous package that linked to GDAL is going to be out, so we're going directly with SF right now. El ticket, okay. I don't know if this works. Okay, the computer. So this should work. So I was wanting to show you a little bit more of TMAP, but it does not make a lot of sense without something to plot. So tomorrow, when we work with biodiversity databases, we can come back to TMAP, you can come back to TMAP, and to see more details about how to plot, to do thematic plots. But what I wanted you to see is the structure of the SF objects. As I told you, I will sit here just. As I told you, TMAP has a syntax similar to gplot, so basically you have to tell them which is the shape that you want. And when you read something externally, you have to read it inside with read SF and say which is the shape that you're going to add. And I just added one extra line, that's the borders. But you have, and you feel free to check the help of the package, because you have bubbles, you have legends, you have lots of options to make very nice maps. We can explore them later. My intention was to show you how an SF object, SF stands for simple features, and I already said that it's like the new version of spatial data inside R, and it should be working fine with the tidyverse. I know Sarah is not a super fan of tidyverse, but I want to know, did you use ggplot in the graphic? Were you using dplyr, filter, mutate, and verbs with pipes? Not a lot. Are you familiar with dplyr syntax? No? Okay, so we're going to see this kind of work because these kind of packages work very well with the syntax of dplyr. I am not a fan, I am not going to say, you have to use the tidyverse or you have to use this kind of syntax. I think that anyone should use the tools that best suit them. But the fact that they work well like data frames makes them super easy to subset and to do some operations inside. So I guess you all did names, world, and class word. I should have my own. That's okay. I will open intro here. Pode projetar a tela? Aqui. Tá boa. Ignore update. So what I am going to do here, I don't know how you did it, is creating a new script for today as a good practice. Please. Yes, I will. Of course. Control bus. Better. This is weird. I will get used to this mic. So basically, we are just going to load SF and map and ask for data world. And I want you to see that the classes, when you ask for to R to tell us what is the print of the object world, it will tell you this information. It will tell you it's a simple feature collection. It will tell you how many features and how many fields it has. So features are basically every one of the polygons, and the 15 fields are the columns, are the variables. It will show you the geometry type that I was telling you before, the multi-polygon, and the bounding box. So which is the minimum and maximum values for each coordinate in this sense. So of course, if it's the world, it's from minus 180 to plus 180, and between minus 90 and plus 90. This is because nothing lies above plus 83. It will tell you the geodetic CRS, and it will just print a head. So you can just take a look at the kind of data that you will have. And it looks like a data frame. This is something that is nice about SF, because it looks and it works like a data frame. But the last column is a column that is called geometry. And the column geometry looks like a column, but actually it's a collection of multi-polygons, because each country is in itself a multi-polygon. So something very, very neat and very the fact that you can create columns that are lists of lists inside R makes it easy to embed and to like nest structures. So this geometry can be treated like a column, and you can take it out. But also you can explore the geometry part inside. So we are not going to go super deep in this, but the fact that you have a geometry in the same data frame is nice for you to explore. I had, wait. And what I was doing here is that when you execute world as a simple feature, you have dimensions, and you have 15 variables. And when you plot using this syntax, you're basically plotting each of the variable. And depending on, it looks like a data frame. If you plot the lines, if you decide to plot like this, remember that in R, everything is lines first and columns after the virgula, after the comma. The virgula. So if you plot a line, any line, it will just plot the first polygon. So this is Albania, and this is not interesting for us. But I wanted you to see that it has the same syntax as subsetting a data frame. So, and if you plot the column is after the comma, it will plot the first of the 15 variables. Yes, if you do, you may have executed plot world. It will say you, hey, you have too many columns here. I will only plot 9 because it's too much. So some of you asked me about this warning, and it's natural. It's just a way of printing for now. Yes. Can you? Yes.
So we here are uploading in the one word one, or what is this information? Why we have these colors here? What is this? Because we have here, this is the head, right? So we have.
It's just using a qualitative scale. It has no information. So the ISO is the
ISO.
official ISO code for each country.
Okay.
When it's categorical, it will print in a categorical palette.
Yes, like this.
So it has no information. The only requirement of a categorical palette is that contiguous polygons do not have the same color.
Okay.
So that's the only
yeah,
thing.
because they
Because
don't have
otherwise
the
you
name,
don't have-
the same,
yes.
same name. Okay,
Yes.
perfect.
As you did, like when you plot life expectancy, it has a continuous scale, yes, a semi-continuous at least. Yes? Yes, the estimated population is a plot which has only information, actually. The difference is so large that you only see China and India. Yeah, it's absurd. So when you explore, like I suppose that Sarah taught you like to print summaries and heads and tails to explore the data. So this is nice because you can do this. If you execute world geometry, I don't know, I didn't put it because it would print a lot of things. But if you execute world geometry, I will do this in my session here. World geometry. You will see that it has, I was calling with a syntax for a column. I was just calling with a $sign, but it told me more things that I was expecting. It tells me that it has 177 features. The geometry type is a multi-polygon. It tells me things that already are repeated in world, but that means that geometry object is an object in itself. And you don't have the data, you only have the multi-polygons here. So as I was saying in the tutorial, that we don't need to understand, like, it's a good point to start understanding the deep structure of SF objects. SF has lots of vignettes in case you want to continue explore. It will explain the nature of everything, the operations that can be done. And the practical functions for us is that they work as data frames. If you want to extract the coordinates, it will give you a data frame with the x and y's in every as two columns. If you want to drop the geometry, it will just give you back. I am creating here an object that has that is dropping the geometry of the shapefile, and it is a data frame. And the bounding box can be assessed with this function stbbox. So these are the 15 variables for world. And what I was telling you about the dplyr syntax is that TM shape, what the pipe does basically is to put the object before the pipe as the first element of the filter. I don't know how you could write in dplyr something like filter world, and then the logical operation that is continent equals South America. But the pipe takes this before, so you say start with world, then pipe it, and you don't need to use this inside. And this works the same inside tmap, because when I showed you the first map, we had a TM shape. We were using TM shape and putting world here. I am telling the map that I want to use this, and then you continue building your map. but you could use it in a pipe syntax. So after you filter it, if you see the pipe at the end of the line, you can just continue and tell them to add a shape without anything inside the parentheses. So I hope this is clear for everybody. Cool. And then you start doing the map. And you have to change the pipe for plus signs because you're changing reference. Now you're changing for using tmap. You can also create new variables. And the way to do this in dplyr syntax. Wait. Here. Is that you can use mutate. You could also use the classic way of creating columns. I don't know if you have any question about this syntax of mutate, or if I have to go back, or everything is cool. Like anything that is not clear. You have seen the in operator. If else. Okay, so if else is a logical operator that will take that. Not only in R, but in general, when you work with if else, you create a logical clause. A logical clause can be anything, like it can be any logical clause. And the first argument after the if it's true, then what do I do? So if it's true, then what I do, and if it's false, then what do I do? So what we are seeing here is if else. If the code of the country belongs to col, bra, or mex, then I forgot Argentina, I'm so sorry. Didn't I? Yes, I think that's the 4 countries we're from. Yeah, that was basically that. Yeah, but if the code of the country belongs to this character vector, if it's either col or bra or mex, then after the first comma, please write red. If not, keep it gray. So it's this. If the logical clause is true, then do this. If it's not, then do this. So you're just switching. So this is one way of doing a logical clause that is a little bit more complicated than this, but you could use the same, like if the population is more than 10, then do this. And there is a way in R. Sometimes you need more complex logical clauses. So you can use and, you can use or, and you can use case when. Case when is like a nested structure. So you say case when. If the name of the country is that, then do this. If the population is below that, then do this. So, and you can add lots of logical clauses, and it will just obey you. That's OK for you? So if you want to check, you can execute before this pipe, for example. Just execute this. Just execute until this parenthesis. Don't execute. And you can maybe just to see. It will create, the last column will be our country, and it will be gray, 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 and then a couple of reds. Yes? But you can do that with anything. This is just a very, very simple example. Cool? And I am telling them, when I say the field, like, please use our countries, the column that I just created, to create the field. But this is just.
And we can't add a row, right? I think it's not possible because we just have like the countries in the word.
Yes, I will just put the microphone again because I didn't hear. And you can.
Sorry.
No problem.
And like we can't add a row because I believe that the rows are the countries, and like we can't add a country in the word, so it's like unchangeable. But
to add the row, I don't understand.
Add a row, like add a row. Linha.
How would you like to add a row? I don't understand.
Like, because in our countries, it's only columns, right? Like the...
If you want to, but I don't know.
I don't know, I thought that the word would be like a data frame that would like have columns.
You are adding columns instead of rows.
Yeah.
Yeah. Okay, yes. In this kind of features, it does not make any sense to add rows, but I guess you could merge two objects that have polygons, like to put rows together if they are the same format. You can also take out, the first example is taking out rows. Let me show you.
You filter, right?
Yes,
Like
exactly.
you
It
filter
does not
by
make
the
any sense
name.
to add, but it does make sense to delete, to filter. So this filter operation is taking rows out. But you could do, yes, like filter only our countries, like filter and use, this was because of the continent, to have all the countries, but you could filter by another clause, and you take out, or you select some rows, instead of adding them, but I understand that, yes. It's the filter is the operation for rows. Yes.
Okay.
So, is everything okay for you? I know this is, I have no idea if it's too basic or if it's like, no, that's okay, or if it's like, I have no idea. Like, but let me see, what we want to do is like, if you have more questions, if we want to go deeper, you take your path, you can ask us anything, you can just, hey, I was seeing that, I already saw that. Yes, I know that some of you never worked with geographical data, and some people, when they start using geographical data, they don't use R, they use other frameworks. So this is basically, we are going to continue tomorrow with point data. So this is only the beginning. I don't know if you had any trouble or question about how to save a shapefile from the disk. Today, I am not, like what I did not do is taking shapefiles out from nature. Like how do you load a shapefile like I show you in the map? But I can let in the page the files for the map that I show you early, like the reserve. It has lines, it has a train, it has a road, and you can compare the code of how you build a map and how you do that. So I will leave that in the page. So you execute, and that map has something interesting, is that you have to transform the coordinates, because some of the data were in some CRS and some were not. So you can explore that data at home. Yeah. What I wanted to show you here about the way to organize the data, because we always create new folders and subfolders to do the data. Sometimes you can do that outside of R, you can do it by hand, you go to the file explorer. I like to use dir create, so we have the same structure. If we use that function that creates the folder, we don't have the trouble of you going by hand to the place that you are. So it should work. Do you know why the recursive is equal to true? Does anyone know why the recursive is equal to true? Or you can check in the help. We're just creating a folder. If you want to go to the help, or if you already know that, why is recursive equal to true? Go to help, just go quickly to the help of the function. I know why. I'm just like, no, but it's something that happens a lot with folders, not only in R. We want to create them. Oh, go ahead. I need a mic. No problem.
So you were asking why recursive is true.
Yes.
Is it? I'm not sure. Is it for so we can save multiple files in the folder during the script?
No, right now the dir create only creates the folder structure. Okay. So you can tell R, you can say, hey, I want to create data. Are you checking this, or do I give the answer? Is okay? Yes. So it's only a step of creating the folder structure. This inside the terminal, when you are in Bash, when you are in Ubuntu, the command is make dir, like mkdir. Mkdir outside in the terminal is exactly the same as dir create inside R, and it's recursive because I'm creating a subpath. So I'm telling them, if you can put it false, and it will say like, this does not work. When I say make it recursive, it will create not only data, but only shapefiles. I could do dir create data and not say anything, and then dir create data shapefiles, because now it exists. But instead of doing two operations, I tell him, oh, do it. Just create the structure. And then you fill it. So it's not to add multiple files, it's just to create the whole path. But I have to use the same path in data and shapefile. So this is the way to put everything in order. Data shapefiles, and inside the shapefile you save things. And I wanted you to see in the files how it works. Wait, I will just do this. I have too many. Copy code.
Our shapefile is binary?
Your what? Your
shape
shapefile?
files are binary or not?
Yes, okay. They are not text files, but you can. Are you asking because of Git?
Two. Yes.
Yes, they are not. They are not. You cannot make version control of them.
Okay.
So it depends on your work. Sometimes you. I'll come back to this.
Okay.
Before I. Let me go back. Here. I thought I had a copy code. Copy code here. I'm okay? So, when I created, look at my folder. I don't have a repo like you all have, because I haven't been working with you all. So this is what Sarah left in Git. So I have only data here. Wait. Let me show you with the mouse. I have data here, and I have a folder that is processed and a folder that is raw. And because it's spatial data, I didn't want to mess with the whole structure, because I know the spatial data is raw data, but it's binary data. You will have multiple files. So what I try to do all the time is to separate spatial data from the raw. You could put it inside raw, of course. Inside raw you have CSVs, but for the sake of organization, I thought it would be more interesting to separate them. So data and docs are here. I want to know if you follow me. Yes. So I'm just creating data shapefiles right now. And what it's doing, it creates shapefiles here, and it inside data. So I don't need to create. Actually, I didn't need to make it recursive because data already existed, but that's okay. And I want to write the object into data shapefiles, and I will tell them I want to write it as bra bra.shep. Yes, and I won't do this right now. I will just explain why this is here. Because my computer, it's the first time that it's writing. I don't need to delete anything. Let me just check with you. I am just, okay. Here, I'm executing. And what did it do? Please, here. Inside data and shapefiles, it created for what I told you before. There are some three, HAP, DBF, and there's PRJ. So SF already creates PRJ. If we open here, you will see how the projections are written inside R. And this is a notation. You don't need to know it's like super needed, but this is called WKT. It's well-known text, and it's a way to describe each projection. So it is telling that you don't know the model of the the spheroid is here. You have the data, the datum, the origins, and you have the origins of the grade. The unit, which could be meters, but in WGSS is degrees. So it's a text that the computers can read about how CRS work. And the rest of the data, what's your name, sorry? Lucas was asking about the fact that these are not text files. These are binaries, except for DBF. DBF is a database file. So when you have the data, where you have the data is inside that. So I am just clicking it and I am opening it. It will open basically a LibreOffice instance, so we can explore. And this is the database. I will just make a zoom. This is the database that is inside the shape. This happens a lot, codification problems, because probably I read it. Did you see? I just chose the wrong codification, so I should have done it better. I will try to do it better. I chose Unicode, and it's probably not Unicode. Maybe it's... And maybe it's ISO. Okay, so ISO it was. It's understanding the special characters right now. And this is the table of data that is associated to that shapefile. Are we okay with that? So this is the database. We'll just come back to, yes, here. And this is the part of the file that has the polygons. I don't know exactly the difference between those two, but the fact is that a shapefile is a collection of files. This is the important part. And what happens if I want to write it again? I will execute again my command in line 16. And I will ask to write the object bra. This is the object. And the computer protects it. It says, it's an error because it already exists. You cannot overwrite a shapefile without a warning. It will not leave you. So this is why I have, and you have in your code, a delete option. Because I was repeating the code a lot, I needed it to run. So but this is good. It is protected. I will delete it. And now it is able to write, okay? So this is why delete DSN works. And in general, the shapefiles cannot be overwritten again. Sure, give me a,
So I have two questions. First, I don't get still the recursive parameter. It's like if you don't have the directory, it creates it? Like
yes, yes.
Even if you have it, it puts things inside of it, right?
If you have it, it will tell you it already exists, and there's an option to drop this warning. If it's not, it will create them. If you ask for a subfolder and you do not put recursive, it will say, I cannot do anything. If, for example, data didn't exist and you wanted data recursive, it will tell you, I don't know where to go. So when you say recursive, it will create data if data does not exist.
Okay, and with the delete layer, you put it so you can create again. Like
Yes, exactly.
Okay.
Because it protects for overriding, and this is common, very common in this.
Okay, thanks.
The rest of the code was just to check that you read a shapefile with this command. So this works for everything that you download or not. Yes. And the same thing happens with raster. I guess you already created this. I was having trouble with this earlier. I am creating a path. For example, data already exists, so I wouldn't need it. I wouldn't need it to be recursive, but raster is creating another subplot. I have this. I have this. If I, for example, if I do it again, it says, hey, in the create, data raster already exists, so I won't. So it's just to check. And I am using a function from raster to get some data, data. And the option, I want you to check the files. What happened here? So it's saying that raster is going to be out. And it will be using only the geodata package. But also, if you go to the subfolder with the raster, it created, this is from WorldClim. Maybe you have heard about WorldClim. It has climate variables for the whole world, maximum temperature, precipitation, minimum. This is very used in species distribution modeling, in other kind of modeling. And what you have here is a subfolder with a zip with all the data, but it did this automatically. It extracted from the zip these shapes for every month. So it's the maximum temperature for the 12 months. But if you see your session, the object is here, so you don't even need to read it. It's here. You have tags, you have Tmax, and you can check that it is a raster stack, which is what I was telling you earlier, that the rasters can have multiple layers. Okay, so we are going to take some points tomorrow. We're going to extract some data from the raster data. We're going to check how this works. And the dimensions of this object are the number of rows, the columns, depending on the resolution. And this 12 means it's 12 layers because of the 12 months. Okay? So a couple of basic functions to explore raster data are the extent, that is equivalent to the bounding box in shapefile, and the resolution. And this is in degrees. Okay? So tomorrow we're going to be doing a little bit more about this data, but I wanted to, I don't know why this is, I want to know like if it's okay, if it's too, so what I told you, this is the tip of the iceberg. This is extremely short and extremely shallow. Please check the task views of spatial data and movement ecology and whatever is good for you. And we are going to start doing some downloads tomorrow. I will leave everything in the site. About Git in these settings, some of the data are extremely heavy. So for example, a .zip file wouldn't be good to put in the commit. So I don't know what you have. Do you have similar Git Ignore files, I guess? You have, so sometimes the data that you are using as shapefiles are something that is changing a lot, but it's still a binary. So it depends on the context. When I do not change a lot the files and it's going to be there forever, and I won't commit again, and it's not too heavy, maybe I put them in the repo. So my collaborator takes the files with them, or they will have to re-download. But if you're going to change a lot of the files and it's not exactly the core of the work, you may want to ignore them. Just don't push shapefiles. You just don't push rasters. So this is like one of these cases where the good commit practice has to be like let's think what it means to make a large push. I wouldn't push today because it's not necessarily like large data, and because you have dir create, and you have the code that downloads the data. If you have these two codes in your script, you can have the data again. If you didn't have the code, that ensures your reproducibility, so the output does not matter. If you have a shapefile that you took from another place, then maybe you should have to at least explain how you got the data, or maybe put the data into your repo, okay? Fine. This is something that changes a lot depending on the project. Please.
So we add the extensions of the shapefile on Git Ignore, or we do like a zip file and add this on Git Ignore?
I think we should add the whole extension.
The whole extension?
Yes, I will do that with you right now. Like,
right.
Yes. I was going to open the Git Ignore. How you have it? Because I don't know what you have been. I see that you have an HTML and all zip files. So all zip files should be already ignored. The zip file with the raster that was downloaded should be already ignored, so it won't show up in Git. If I am going to, are you using the terminal? Are you using both? Sarah will kill me. If she will say that I'm not. I just want to show, I will add this and I will just de-add it. I don't want to add it forever. I just want to show you what happens. If I add the shapefiles, it will become so slow. Okay, I killed it already. Yeah, I killed it. Because it's heavy files. It's the world, it's shapes. So you don't even need to do these kind of things. And since we were working with world, so it's an internal data set, it doesn't make any sense. What I wanted you to see is how it works in the files. So you will have, I don't know, I'll have to think. So maybe we have .zip ignored. Maybe we ignored this. Or we ignore data, shapefile, and we ignore data, raster. It's not the same mechanism, because this, you would be ignoring any shapefile inside the whole folder in other places. Or maybe we just ignore this folder. Maybe this is quicker, and maybe this is safer. So instead of doing this via extensions, you can ignore the whole folder. So it shouldn't even appear in Git when you use it. That's okay?
Can we do both?
Yes, it will do both. If you have shapefiles outside of these folders, it will ignore everything outside of these folders. If you ignore this and you have file types that are not this, it will ignore everything anyway.
I mean, it would be a good idea to write both, ignore both the archives and the folders.
I think for now the folder is okay and it's safer. Because if something we want to add, we have to check. But I think this is safer and this is only the path. So we can come back. Okay, so in Git Ignore, please ignore data, shapefiles, and raster. And you can play with this data. Okay? And yes, no, okay. So just to show you what happens when I add things. It took forever, and it added DDF and this. I wanted to show you what. With the zip file, it's also like it's so heavy. Like the data, raster. This zip is 6 megas. It shouldn't be even doing this. If I do this, it will tell me I am putting heavy. It didn't tell me anything, but it didn't add the zip because the zip was already ignored. Okay, so I will not add anything. I'm just going to delete this part. I am just going to de-add it. And we are going to ignore these two files. So git ignore here. And I am going to write the same as you are going to write here. Wait. Let me know if you have any questions, any comments. So here. So when I save git ignore, it just ignores, okay? And what changed and what needs to be committed is the .git ignore, which changed here, okay? So this is the only push I am going to make today. And the script, the tiny script. Please.
If I have not created those paths yet, it doesn't matter? Like, it would be a problem to...
No, it doesn't matter.
Okay.
Like for now, that's okay. And this is changing because our endings are changing. So I will just commit this. Like. Okay. And the tiny script with the tutorial should be pushed to, yes. Okay. Thanks, everyone. I think it's, yeah, we're 10 minutes early, but yes, anything that you want to add, anything that you want to ask, I am here. It's okay. Nice to meet you.